Hello science learners. This is your video lesson guide in Science 10 for the first week lessons. You will learn about the different layers of the Earth, the crust, the mantle, and the core. You will also learn that the Earth's lithosphere is divided into major and minor lithospheric plates. What you are expected to learn. After going through this video lesson guide, you are expected to A. Describe the Earth's lithosphere. B. Differentiate oceanic and continental crust. C. Infer that the Earth's lithosphere is divided into plates. D. Identify the major lithospheric plates. And E. Determine the scientific basis for dividing the lithospheric plates. Have you ever cracked open a hard-boiled egg? If you had, then you probably noticed that it has three layers. The thin covering or the shell, the thick middle layer or the egg white, and the more intact core or the egg yolk. The layers of the egg can be associated with these layers because the Earth's structure is very similar to these layers. Lithosphere is the solid part of the Earth, and it is constantly changing. The appearance and conditions of Earth's lithosphere today are believed to be different from what they were millions of years ago. These changes took place from pre-Cambrian, Paleozoic, Mesozoic, and Cenozoic period. The changes of the Earth are also observed from the captured images of the orbiting satellite near the Earth, and from outer space mission over the years. In 1967, a single satellite image of the Earth was taken from ATS-3 satellite, in geostationary orbit 22,197 miles above the Earth. In 1972, a single satellite image of the Earth was taken from Apollo 17 on lunar mission, 2,800 miles above the Earth. In 2002, a composite satellite image of the Earth was taken over 8 days from Terra satellite, 443 miles above the Earth. And, in 2015, a single satellite image of the Earth was taken from DSCOBR satellite at L1. 930,000 miles above the Earth. Geologists, scientists who study Earth's structure, have provided us with information regarding the origin, structure, composition, and nature of Earth. The Earth can be divided into one of two ways. Mechanically or rheologically, meaning the study of liquid states. It can be divided into the lithosphere, asthenosphere, mesospheric mantle, outer core, and the inner core. On the other hand, chemically, which is the more popular of the two, it can be divided into crust, which can be classified into continental crust, and oceanic crust. Mantle, which can be subdivided into the upper mantle, and lower mantle. Core, which can also be subdivided into the outer core, and inner core. Fun fact. Did you know that, except for the crust, no one has ever explored these layers in person? In fact, the deepest humans have ever drilled is just over 12 kilometers that took 20 years. Think of the layers of the Earth like the layers of a cake. I will give you 10 seconds to think on how you can relate each layers of the cake to the layers of the Earth. Okay, time is up. Let's see if you got it correctly. The icing of the cake represents the crust, which is the thinnest outermost layer of the Earth. The red velvet layer of the cake represents the mantle, which is the thickest layer of the Earth. The yellow layer of the cake represents the outer core of the Earth. And the white layer of the cake represents the inner core of the Earth. The Earth's surface is covered by its thinnest layer, the crust. Earth's crust is like the shell of a hard-boiled egg. It is extremely thin, cold, and brittle compared to what lies below it. The crust is made of relatively light elements, especially silica, aluminum, and oxygen. It's also highly variable in its thickness. Under the oceans, it may be as little as 5 kilometers thick. Beneath the continents, the crust may be 30 to 70 kilometers thick. Land is made of continental crust, which is 8 km to 70 km thick, and made mostly from a rock called granite, sedimentary rocks, and metamorphic rocks. The layer beneath the ocean bed is made of oceanic crust, which is about 8 km thick, and made mainly from a rock called basalt. Oceanic crust is also made up of iron, oxygen, silicon, magnesium, and aluminum. The Earth's mantle. At close to 3,000 kilometers thick, this is Earth's thickest layer. It starts a mere 30 kilometers beneath the surface. Made mostly of iron, magnesium, and silicon. It is dense, hot, and semi-solid, which made this layer solid but capable of flow. It makes up 84% of Earth's volume. The upper mantle is up to 670 kilometers below the Earth's surface. The lower part of the upper mantle is made from both solid and melted rock or liquid, while the rock in the upper region is stiffer, because it's cooler. The mantle's outermost zone is relatively cool and rigid. It behaves more like the crust above it. Together, this uppermost part of the mantle layer and the crust are known as the lithosphere. Near its upper edges, somewhere between about 100 and 200 kilometers underground, the mantle's temperature reaches the melting point of rock. It forms a layer of partially melted rock known as the asthenosphere, also known as weak sphere, soft layer of the mantle on which pieces of the lithosphere move. The hot material or magma in the mantle rises to the top of the mantle, cools, then sinks, reheats, and rises again. These convection currents in the middle mantle cause changes in the Earth's surface. The lower mantle is found between 670 kilometers and 2,890 kilometers below the surface, and is made from solid rock. The rock is hot enough to melt, but is solid because of the pressure pushing down on it. The temperature at the lower mantle is 3,000 to 4,000 degrees Celsius, and decreases roughly 1,300 degrees Celsius at the base of the crust. Earth's core is divided into different zones: the outer core, and the inner core. It is thought to be composed mainly of an iron and nickel alloy. The core is Earth's source of internal heat because it contains radioactive materials which release heat as they break down into more stable substances. Inner core is the huge solid metal ball that has a radius of 1,220 kilometers, or about 3/4 that of the Moon. It's located some 6,400 to 5,180 kilometers beneath Earth's surface. Extremely dense, it's made mostly of iron and nickel. The inner core spins a bit faster than the rest of the planet. It's also intensely hot, about 5,000 degrees Celsius to 6,000 degrees Celsius, almost as hot as the surface of the Sun. The metal at the inner core stays solid because of the incredible pressure surrounding it. Outer core is a liquid layer of iron and nickel that is 5,180 to 2,880 kilometers deep below the surface. Heated largely by the radioactive decay of the elements, uranium and thorium. The outer core flows around the center of the Earth, and the movement of the metals creates our planet's magnetic field. We are done with the structures and composition of the Earth. It is time for practice exercises. Practice exercise number 1. Crossword puzzle. Identify the word described in each statement to complete word puzzle. You can pause this video lesson guide while doing the practice exercises. Let us now proceed on the second part of these video lesson guide, the major tectonic plates and several minor plates. Along with the upper zone of the mantle, the crust is broken into big pieces, like a gigantic jigsaw puzzle. These are known as tectonic plates. These move slowly, at just 3 to 5 centimeters per year. It may be related to heat-driven convection currents in the mantle below. In time, these plates will converge, pull apart or slide past each other. Those actions cause most earthquakes and volcanoes. The Earth's surface is a very dynamic place and has not always looked like this. Earthquakes, volcanic activity and other phenomena have been changing the face of the planet for millions of years. The key geological theory that explains how the Earth's surface changes now and has changed in the past is called plate tectonics. So what exactly is the theory of plate tectonics? And how was it developed? According to this theory, the Earth's crust is like a jigsaw puzzle made up of giant sections called tectonic plates. These plates float on top of the mantle and so can move around the Earth's surface. There are 10 major tectonic plates and several minor plates. They are North American Plate, Pacific Plate, Caribbean Plate, Nazca Plate, South American Plate, Eurasian Plate, Philippine Plate, African Plate, Indo-Australian Plate, Antarctic Plate. North American Plate. It includes the continent of North America, part of western North Atlantic and Greenland. Pacific Plate. It includes the most part of the Pacific Ocean, and the southern coast of California. Caribbean Plate. It includes mostly oceanic tectonic plate underlying Central America and the Caribbean Sea off the north coast of South America. South American Plate. It includes part of South America, and part of western South Atlantic. Eurasian Plate. It includes part of eastern North Atlantic, Europe, and Asia, except India. Nazca Plate. It includes the part of eastern Pacific Ocean adjacent to South America. Philippine Plate. It includes the islands of the Philippines adjacent to Pacific Ocean. African Plate. It includes Africa, eastern South Atlantic, and western Indian Ocean. Indo-Australian Plate. It includes India, Australia, New Zealand, and most of Indian Ocean. Antarctic Plate. It includes Antarctica, and the Southern Ocean. We are done with the major tectonic plates and several minor plates. It is time for another practice exercises. Practice exercises number 2. Label the following with the names of the major tectonic plates and several minor plates. You can pause this video lesson guide while doing the practice exercises. It is activity time. Layers of the Earth. Do the activity below and make sure to follow all the procedures. Answer the guide questions. Well done. You have completed this video lesson and I hope that you have also completed the practice exercises, activity, and evaluation. See you next week, and thank you for watching.